Hello everyone, today I'm going to go through a little demonstration of electrolysis. So electrolysis is the splitting of an ionic compound by running an electrical current through it. So you have an ionic compound which gets changed into the elements from which it is made. So what I have here is an electrolysis cell. I have filled it with a solution of sodium chloride, so regular NaCl inside that water there. It's got two graphite rods. What I'm going to do is, just to show you, I'm going to test the pH. So I've got some litmus paper, blue litmus paper. Oh, doesn't change. That shows us that sodium chloride solution is a neutral pH. Just to prove it, I'll show you it with red litmus paper as well. And as we can see, yep, there we go. It is staying the same color, does not change. So sodium chloride solution has a neutral pH. So I'm just going to connect my electrodes. The black wire here is connected to the negative terminal, so it's going to be the cathode. The red wire is connected to the positive terminal, and so will be the anode. I'm just turning the power on. There we go. We can see some bubbles are starting to form there. So those bubbles are forming at the cathode. So we can see from this half equation that that is going to be hydrogen. Hydrogen gas is formed at the cathode because hydrogen is less reactive than sodium. You can see quite a lot of it is being formed there quite fast. At the anode, there is another gas being formed a bit more slowly, and if we again take a look at the half equation, we can see that that is chlorine from the chloride. Because remember the rules, if you have a halogen, then you get the halogen gas formed. If you don't have a halogen, it would be oxygen gas. And at the cathode, the more reactive element stays in the solution. The less reactive element, in this case hydrogen, gets formed. So we're making quite a lot of hydrogen there. Now it isn't really showing up on camera very well here, but the bubbles on the left of your screen on the anode, which are chlorine gas, they are actually a very faint yellowish color. It's not really showing up very well on the camera. What I'm going to do is I'll add something later to show that that is chlorine. But at the minute we're just gathering the various gases here. So we've got hydrogen and we've got chlorine. Remember that opposites attract and they get discharged to their elements. I'm just going to fast forward a little bit while this builds up. I'm going to test the hydrogen gas now, and as you will all probably know, the best way to test for hydrogen gas, there we go, it gives a pop sound when you add a flame to it. I'm not sure how well that came across on the audio, but that was that. So over on the other side we've got some chlorine gas. Now there's much less of it being produced here, but the way to test for chlorine gas is by bleaching damp litmus paper. The reason there's much less of it being produced is because the hydrogen ions are at a much higher concentration than the chloride ions. Let's see, I might not be able to catch all this, but don't worry, I can add something later to prove that this is in fact chlorine. So if this is chlorine, it should bleach the litmus paper. Let's see if it is going to do it. Letting it build up a bit more, trying to get as much chlorine as possible. Alright, let's give it a go. Don't know how well that's going to come across on camera. The very tip of my paper there has gone slightly white. That's not the best result I've ever seen. It is chlorine. Okay. What I can do to show you that it's chlorine a different way. So what's left behind in this solution when you remove the hydrogen and the chlorine is going to be sodium hydroxide solution. So we tested the pH at the beginning of this experiment, and we saw that it was neutral. What we will have, once we remove the hydrogen, is we'll have sodium hydroxide solution left. And sodium hydroxide solution is a base. So we should have a high pH around the negative cathode. The chlorine will bleach the universal indicator. So I'm going to add some universal indicator now. And we should see that it becomes colorless around the anode. So there's my universal indicator solution. So we can see already that it has gone alkaline. It's that blue color. Over on the left of your screen there, where the chlorine is being produced, we can see that it's losing its color. That is not changing pH. What is happening there is it is bleaching the color from the universal indicator solution. So just on the screen, just sum that up. When hydrogen ions are removed, the solution becomes an alkali, so it goes blue. And when chlorine is produced, it bleaches the universal indicator and it goes colorless. So we can see there it's gone colorless. To sum it up, the products of sodium chloride solution are hydrogen is produced at the cathode, chlorine gas is produced at the anode, and the solution becomes sodium hydroxide solution. Alright, thanks for watching.